The first thing I would like to talk about is that we'll start a data structure today. And I originally have a set of data structure and algorithm slides, but I don't think it's well organized. So I'm not going to 100% following it. So first things that I would like to say the textbook, okay? So textbook is the problem solving and the data structures using C double plus, okay? So we are looking at this Longstone version. Actually, it's free and it's online, so we can share, okay? Hi, Helen, how are you?
Good, how are you?
Yeah, we welcome Helen to join us as well because last year I teach the DSA, but in the middle, my health condition is not good. I got hospitalized, so the course is cut short, okay? So this one is the textbook. It's called Roomstone Academic. Okay, this one is a textbook. Okay, so we will pretty much follow this textbook's chapter order, but we may not teach the same thing because some of the chapter this textbook is too easy. Okay, it's too easy. Okay, so let's look at the beyond language. Okay, beyond language. So far we learned C, C++, Java, JavaScript, Python, and all of the language up to the level two. Level two is oriented programming and recursion and the algorithm. So we talk about that quite many times. And today I would like to talk about this level three, level four programming language. Okay. So this is a course that I'm teaching at Lewis University, Lewis Friars. So I would say probably very close to where Helen is. I think it's a little bit close to Helen's locations, but Lewis University. Okay, this one is where I'm teaching. I have been teaching here for many years. So if you ask me for recommendation later, I will use the letterhead of Lewis University to write you for the summer camp, okay, or college application. So that is okay. So Sherry, I wrote some recommendation for you before, right? Am I correct?
Yes.
Yes. So actually, I do write some recommendation later for Luce Sherry before. So anyone here, if you need a recommendation later, let me know, okay? Usually I would suggest you still get the version from your teacher, your high school teacher. But if you do want my version, or your teacher don't refuse to write some good one for you, then you can let me know, okay? So this Lewis University. Let me actually show it on map. Okay, let's see. It's a map. Okay, and then let me try to. Okay. No, this is my map. And actually, let's try Lewis University. And then let's have a direction. And then starting from, let's say, Iowa. Okay, so it's a 4 hour drive, not far away from your Iowa. Okay. Anyway, let's go back to this one. So basically, let's look at level four, this one. So let me jump to the introduction, right, go to here. This is the chart I want to show, okay? So this one show you how you study computer science in college. So especially for someone like Sherry, I'm talking about this primarily for you, okay? So you would take the AP ComSci principle. So the principle is under the language. It's right here. It's below it. Usually before you learn any computer science, you do learn something called computer science principle. So the fundamental principle actually talk about everything else here. Okay, should cover everything else here. But your CSP should be below here. But usually the AP concept principle is very poorly taught in high school because they don't have good teacher. They also don't have the good curriculum. But anyway, you try to understand what is network, what is OS, what is hardware, what is language, what is programming, what is algorithm, what is data structure, what is uh, cryptography, every topic possible in CS. Then you will move on to college. So college level, you learn Java 1, 2, C double plus 1, 2, Java 1, 2, Python 1, 2, okay? So basically you go 1, 2, and then you go to 3. 3 is DSA level, data structure and algorithm. Okay, so usually in level 3, you only learn one language. You may learn C double plus, you may learn Java, okay. But Python fewer because Python is not good in terms of as a language for teaching the DSA. Okay, so in data structure and algorithm, what you learn is the organization of your data. That's called data structure. So you will learn what is array, what is list. So you need to know about how to draw this conceptual diagram. What is hash table, key and value? What is tree? What is graph? Okay, so these are the topics that the data structure teach. And then you need to know about what kind of algorithm will operate on it. So algorithm on top of table, algorithm on top of list, algorithm on top of tree, and algorithm on top of the graph. So that's the graph. So this is what the level 3 teaching about. Usually, there's level 3 in this course. So if you go to community college, okay, here I'm teaching you the basic programming one, but if you want to get credit, if you want to get credit and get a dual enrollment point from college, I strongly recommend the Foothill College. California student, no problem, you can register and pay no fee. Free, it's free for California students. For this Foothill College, and they do have online one, okay, and then you say CS curriculum. Out of state, I don't know. Out of state, you have to check with them, okay. So, but maybe okay, I don't know. So here is a CS. They do have a CS, so they have the level 1 CSA. This is about AP ComSci A's level. Okay, this is CS1. So they do offer you ComSci 1, ComSci 1B, 1C. 1C is level 3. Advanced data structure and algorithm in Java. So you can see level 3 is right here. Okay. And then 2A, 2B, 2C is for C. 1A, 1B, 1C is for Java. Okay, and then you have 3A, 3B, 3C. Okay, now one more thing. If you like to get credit from college, you need to check with this guy, assist.org. Steve, you hear me or no? Hello?
Yeah, I hear you.
Okay, yeah, I'm teaching you something important for college application. Okay, you are junior, right?
I'm a sophomore.
Or you are sophomore this year. Okay, so you have one more year. That's good. So let's assume that you take this course from Foothill College. okay? And you are looking for the UC Berkeley's agreement. So you try to get, I'm sorry, this one actually, it doesn't show me the one. It's showing the agreement. Let's see, transferable course, let's look at it. So here, let's type for here college. Okay, versus UC transferable course. So let's go. Okay, and then let's look at the computer science department. And then it will show you the transferable course. All these courses that I'm talking about is transferable. So usually student will pick a 1A, 1 or 2 or 3. My son get this CS 2A, 2B, 2C. Okay. So that's what I recommend you to do it after my course, to take that as well. Okay. You will get your credit. And they are 1A, 1B, 1C, 2A, 2B, 2C, 3A, 3B, 3C. Okay. And then computer architecture, you can take it or not. This is not important, but some people like it. CSA is good. Okay, this one for introduction to data science, this one is also good. This 11, 12, and 18, these are okay course, but for high school student, it's a good, also good because you can learn it in high school, okay? And it's effective only summer 2025. So they are coming, so I would say this one will be super popular. Whether you can get it or not, I don't know, but it's kind of coming, but you check if Fuhio College do offer it. Okay, these are good course. And then CS 20 if you like C#, 22 if you like JavaScript. Okay, these are good courses as well. These are transferable. And then Linux, usually in UC, they don't teach you Linux. So Linux management, these few courses are also good. 40, the software engineering, this is good. Data visualization is good, okay? So these are the transferable courses that if you go to UC, they will at least take it for credit, okay? These are the courses that you should look at. Besides that, you can check with this ASIC.org. This ASIC.org, you can look at the agreement, okay? So sorry for Helen. This is only valid for California's university and high school. Okay, so let me try to get agreement between Fuhio and okay, other UC you need to check. Okay, so here let's do UC Berkeley again. Let's just type it Berkeley. Okay. So let's view the agreement. So they have agreement and you go to, let's assume that you go to the X department, okay? Nowadays, I recommend X instead of computer science. So let's look at X. So this X department will tell you what courses they okay. So right-hand side is the Fuhio, left-hand side is UC Berkeley, okay? So Math 1A, 1B, that actually is calculus, that's good, okay? Calculus, you can swap for it. And then you take the differential equation linear algebra from here, 2A, 2B from Fuhio College. You can change it for the 54, okay, linear algebra. And 1C, 1D, you can change it for multivariable calculus. So Fuhio College, this is good. 7A physics, double E, okay, 7A physics, AB, you can use Fuhio College general physics to change for it. And then your English writing, you can use AP Comes Literature or language to change for it, but you can also take it from community college to swap the credit. Okay. Okay, this you can take a look on this one. And then next one, this is biology, this is a copy chemistry, usually chemistry one. If you don't have AP chemistry, you can use that to swap it. Okay. These are actually good for X. Okay, so that's bypass the chemistry. There are many chemistry courses. And then okay, let's let go. 61A, the language, there's nothing you can use. Okay. And then 61B, the data structure right here. You can use a put here 1C and 2C to change for it. So the Java version and the C++ version can change it for the data structure at Berkeley. Python version 3C is not okay. 3C not okay. So you have to carefully look at this table. Okay. Okay, whatever. This actually you can take a look on it. Okay, this one is the agreement between Berkeley and Foothill College. Okay, so what we would like to say is that, okay, so why are we doing this data structure? Since it's a college course, why are we doing data structure? Number one, your user code is basically after this. Okay, it was used to be after the level 2, and you do a bronze level. But now bronze level is almost like gold level. So you see the bronze level moving toward after the data structure. So become harder and harder every year. That's the problem. Okay, that's a problem it has. So that's why I change and I make adjustment. Last year I teach Java for user code, but now I changed to using the C++ for user code. Okay, but we need to finish this one before you can do really good in user code competition, because user code is changing. Okay, it's changing. So basically, one purpose for doing this data structure and algorithm course is to make sure you can go to the competition. Number two, you want to go to college and continue to move on to programming language and compiler design. Okay, so for that purpose, let's look at this one called CS61A. Structure and the implementation of computers programs. So let's look at this 424 version of the structure and this interpretation of programs. Okay. So this is the schedule. So if you copy this one, okay, and in the internet, and you say it's using Python, they'll show you let's see. They'll show you this one. This one is a textbook in Python. And this version is UC Berkeley's version. So this is exactly the UC Berkeley's version of the structure and the interpretation of computer programs. Okay, this is a textbook. Let me show you. This is a textbook. So this is CS61's textbook. And what's to do about this with our program? So basically, that's the purpose of this programming course here, level 4. Okay, level 4. And this is Berkeley CS61A, the first semester course. So you go to Berkeley, the first semester, you are going to be bombarded by the problem in this programming language course, okay? Besides that, you also need to learn software theory and hardware. And these are four major branches of the courses in computer science. There are many, many courses, but primarily these are four different domains. So why these four different domains is very important. You can go to Stanford, okay, let's call it Master of Science, Computer Science Foundations. So foundation requirement for master program for Stanford, this tell you there are framework and courses that you need to take. So here, required course, logic automata, probability. Okay, these are the required course. And then algorithm. Okay, so this one related to DSA. This one is a hardware check. This one is computer architecture. And this one is operation system and network. So what I want to say is the chart that I show you has the courses that are required by Stanford for the master program. Basically, you are a computer science major, you will need to take those courses. Okay, so which course you need to take? You need to at least finish these in your 4 year of college in order to get to some school like Stanford for the master program. Okay? So Sherry, do you hear me?
Yes.
The reason why I told you this is because that if you go to EE department, that's fine, okay? But you can take the concept of courses, at least these four courses you need to take, okay? This one not needed. This one actually you can take it from double E. This one you can also take it from double E department, okay? You don't care about other courses are the one that list below. These are the core courses. They only list down 3-4 courses, okay? So that's the minimum computer science courses you need to take. And for us, I want you to really understand the programming language course. So actually, you will know more about why we need to study the data structure. So when we teach data structure and algorithm, we will talk about programming language need, okay? So let's move on, okay? Let's move on. I don't need you to have the textbook because we are not teaching this course, but I do want to mention about this course a little bit. So first of all is like, we do teach you data structure and the algorithm, right? And we aim for the competition course. But there is a reason why we want to do data structure and algorithm. So what is the use of the data structure and algorithm? When we will use it? If not competition. If you don't do competition, and any application, you need to use your data structure. Okay, let me ask Sarah. Sarah, what is your view? Where can you use your data structure and algorithm?
USICO hackathon.
No, I'm not talking about competition. I'm talking
Oh.
about the domain or the application, the program that would need it.
Like if you're creating like a large scale project, or if you're like,
You still haven't answered the question. You still talk about general case. So the question is like, what application would need data structure and algorithms? Say you have a hash table. When do you need to use the hash table? You have tree. When do you need to use tree? And you have list. When do you need to use list? Those kind of questions. How about Helen? Helen, can you answer it?
Like when you want to store information in a specific way.
Then you need data structure, yes. But how about algorithm?
Algorithms are when you want to have a specific result, so you create code that will output that specific result.
Okay, so you are still talking about general case, but can you be specific of what application you need to use what data structure?
Oh, like if you want to store like a queue could be used as like a line for like a bank or something, or like a stack could be used as like a first in first out thing, like when you store memory, like local variables and stuff, it would be like a stack. So whatever comes in first is what you would use first. Like
Mm,
whatever comes in most recently,
okay,
so you would use first.
so you explain the one-dimensional data structure well, okay? But how about can you talk about some more advanced data structure like tree or
Oh, um,
uh, hash table or something else that you would the data structure you can use.
so like you might use a tree if you want to like talk about connections between many different things. Like there's this problem or something that was like you want to see how like if you, there are multiple like points or like nodes, you want to see like how they could like connect and how you could spread information through them.
So
Then you would use like a tree.
what specific application you will need it?
Um,
Okay, this is actually you can think about it. Okay, this is the first course for the first class for the data structure and algorithm. So we basically are just brainstorming. Okay, don't feel bad. So Steve, you hear what Helen said?
Yeah.
Hello. What Helen said mostly is okay. Okay, so far he actually mostly okay. Whatever Sarah said is also okay, not bad. Okay, but the problem is that I'm trying to dig deeper, deeper, deeper. Okay, so when you go to for the interview, they would ask a very deep question, keep pushing you in the limits and harder and harder. Okay, that's normal. So don't feel bad. Okay, don't feel bad. That's a typical way that interviewer would ask you. Okay. So I'm trying to give you a picture of what can you do and where people mostly use it. So let's talk about a data structure called dictionary or hash table. So dictionary or hash table, usually you do have key and value, right? You do have key and value, and if you have the key and value and you store them into array, then your search time, linear time will be order n, right? Binary search, you can go down to log n if you do binary search for the key. Sarah, is that okay?
yeah.
And when we use a hash table, what is the complexity? How fast? What is the order, the big O notation, the complexity? We call it complexity. If we use a hash table,
O of n.
no. How about sharing? What's the order of magnitude or order of growth for big O notation for using the hash table, using the dictionary in Python?
Like O one and
Order of one,
O n O log n.
log
Mm.
n, which one? Order of n or log n or order of one? Which one?
Log n. I think. I'm not sure.
No, no, it's not. How about Helen?
O of one.
Yes, it's order of one. It's a constant time, basically. Why is a constant time? Because you just need to put your key value, put it into a hash function. You'll find a location for value. So basically, no matter what key you put in, you'll already be one. So this one search CB, say the Java map, is much faster than array. No matter you are using linear search or you are using the so-called binary search. Sarah, is that okay?
Yeah.
So we want to study this hash table because it gives you the better performance. Okay. So in the so-called the C double plus C double STL standard template library, we do have a map, we do have a pair, okay? And if you know how to search it using the hash table, then it's much faster than you use an array, okay? It's much faster than you use array. So basically, we teach data structure and algorithm. From data structure side, we want to know about the organization of the data. That this point that actually Helen talked about it quite well. That's good. The other part is that we want to get better performance, and that's algorithm study. So that's the purpose of performing the computation or using the algorithm on top of the data structure in order to get the better performance and easiness for programming. That's the purpose. But the application-wise, why are we doing data structure is a different story. It's a different story. So let's talk about one purpose of compiler. Compiler, you do have a compiler right here. You throw in, say, C++ language. You get machine code. You are doing translation in the middle. So this is compilation. Okay? So you want to translate from one language to other language. You want to do translation. So basically, language translation, you have compiler, compile, you do whole file compilation to a whole file. Okay, this is .cpp. This is .exe, right? You can do interpreter. So you do question and answer, one question, one answer type answer. Okay. But no matter you are using compiler or interpretation, you are translating from one language to the other. You are translating from one language to the other. Okay. Got it? And what does this language translation do with us? So why this language translation is so important? Let me ask Helen, why is it so important to do language translation?
So like it can be run on every device, not just like one specific.
Beyond that, that's the old days of purpose. Compilation, interpretation, these are old days. Language translation in the old days, say 1965, when they had a fortune, they want to translate from the fortune language to machine code. They already had the language translation purpose. And then they have COBOL, they also can translate. They have C++, they also can translate. Other than this purpose, what else that important for language translation?
So
Yeah, you try.
so like the computer can run it because like a computer can't read higher level code.
Yeah, but that already old purpose. How about Sherry? Can you talk about it?
Can you repeat the question again?
The question is that why we want to translate from one language to the other. What's the advantage? What's the good thing about it? Why we want to do compiler or interpretation?
It's like every language
Hmm?
does it differently.
Okay, no problem. Okay, you don't know, it's okay. Okay, because I'm asking some tough questions. How about Sarah?
Like different languages have different like processing times or like
You are talking about technically trying to compare different language. That's fine, but that's not a very important topic right now. How about Steve?
Not sure.
Try.
Because
If you go to the interview and you got stuck, then you are out, right? So you need to come up with something. Keep the interviewer be interested on you, okay? If you are, say, stuck for 5 minutes, I think you are out, okay? It's okay, I'm not interview you, but want you to give some answer if possible. So why programming language right now is so important, and compiler is so important? That's because translation is the main topic right now. Let's look at artificial intelligence. What is artificial intelligence? You have a translator. You translate from Chinese to English. You translate from poor English. For example, my writing. You use the Grammarly to translate it to good English. So AI is doing some language translation from one language to the other. Am I correct? Hello?
yeah,
And then another kind of AI is that I look at some image file, say my scanner, and then I generate English. This is pattern recognition, translate from image to English. So they all read in some sort of word or image or something, and you try to see the pattern. So you do pattern recognition, and you generate token, and token got translated to the other language. So outside you don't see the power of the language, but inside you do see it's all programming language. It's all language translation. It's translated from one language to the other. Does that make sense?
okay.
So that's why we want to learn some sort of artificial. When we learn artificial intelligence, before we learn that, you better learn the programming language first. And also you need to learn some of the natural language. So in UCLA, there's a major called linguistic and computer science. They want you to combine the two, computational linguistic, not only to do research in linguistic part, but also to help AI to become better. Okay. Sarah, is that okay?
yeah.
So now let's go into the AI, this language translation part. So next question is, okay, you tell me language translation is important, that I know. Now next one. So what is needed? What is needed? What is the blocks or major functions in language translation? what is the major language translation? So how they do language translation? Okay, this is actually a question. Okay, so this question actually, let's see. Let me bring up the pages. Let me bring up the slices that I have for programming language. So I'm going to use the slices from this course, the course that I'm teaching. The course I'm teaching is actually a more difficult version compared to the Berkeley City one. Okay, this course is a little bit harder than Berkeley CS City one. So let's see right here. Let me try to actually bring up the language interpretation part. Let's look at the introduction. Okay, so right here. So basically, a language translation, basically you have the tokenization and scanner. Okay, so basically you will say, let's assume that you have the language. Say you do have FOR, INT, I equals 0, whatever. Okay, continue. So this is FOR, you see FOR, this is 3 word. Then you consider this is a token called FOR. And then parentheses, you say this is a token for parentheses. So they do tokenization to tokenize each of the language units. So INT is one language unit, one word unit. We call it token. So generate token by token, token by token, token, that's called parser. Parser creating the so-called tokens. And then this token being fed into the scanner, and scanner generate the machine code. So it translates from this from the tokens to machine code. So when you do tokenization, you need to have a simple table, and then try to figure out what kind of table what kind of token it is. Maybe it's for is a keyword for command. Maybe it's parentheses. Maybe it's INT. Maybe it's 3.4. You do know about language tokens and tokens type. Okay, so that's the parser. So basically, let's assume that we have the I like you. So you tokenize it to be I like you, period. So you search for it, it will be a subject, or you can be a pronouns. Like would be basically become a verb. Okay, you will be a subject. It's another pronouns. Okay, and then this language structure got changed because you want to translate it to Japanese. So this I become watashi. Like is ski. Okay, watashi wa. Okay, it's actually you need to translate watashi wa. You first, so it's I you like structure. It actually is watashi wa anata. Anata is you or ski desu. Okay, ski is like. So it's actually subject object, and verb order. So in terms of translation of the languages, your grammar structure got changed. But the grammar structure changed in a systematic way. So because you want to organize your grammar, so you say you actually have a subject, object, verb structure. So it's a tree structure. Is that okay? So in this language translation, we do use a lot of data structure like tree, graph, a table, hash table, those kind of things in the translation. And then it actually achieved the same purpose of doing language translation. Does that make sense? Is that okay? Hello? Is
Yeah.
that okay?
Yeah.
So we go back to this chart. We want to learn programming language and compiler because we all want to know about what language translation is. And nowadays, language translation is so important because language translation is the basis for AI, and AI's main topic is natural language processing. Natural language processing, NLP. Okay, it's natural language processing. And nowadays, natural language processing, we're still learning. So I believe that Christopher is taking this course right now. Okay, he's taking this course right now. And then if you go to UC Santa Cruz, let's don't talk about Stanford. So either UC Santa Cruz introduction to AI curriculum. Let's get the PDF. Okay, let's see if they have a PDF. They don't have this one. Let's see PDF. Okay, this is a flowchart. I don't want. I actually want to. Let's don't call it curriculum. Let's call it syllabus. So course syllabus for UC now. So this one do have syllabus for introduction to AI, artificial intelligence. This one is too broad. This one is extension. Let's don't work on. Don't use this one. Let me see. This one. Let's look at this one. It's forbidden. I'm sorry. How about some search day one? Okay, this one. Let's look at this one. Actually, let's see. Course outcome. Okay. Okay, let's look at it. So if the introduction to AI, you actually will study, okay, what is AI? Is no problem. For Python essential, problem solving and searching. So this one tell you what you need is at least you need to know about Python, PyTorch. Problem solving, this is DSA, okay, data structure and algorithm. Okay, these are basic things that you need. So data structure is very important if you go to here, okay? And then you have uninformed searching, heuristic local searching, optimization problem, constant optimization problem. You are searching optimization, and then basically no, this is grammar net. Bayes net, grammar net. So basically you need to know about the linguistic structure and then building the net. So usually this AI course, they use the natural language processing as the core material. And that's because that you need to learn about language translation from one language to the other. Okay. So basically, when we talk about AI, nowadays AI, as I say, you do have your C++ translate to machine code. That's the original .exe file. That's actually the older purpose. Now we do have translation from English to Spanish. That's one purpose. We do have the character image, scanning image to translate to English. This we call it OCR. Okay, it's actually optical character recognition. Okay, OCR. You may have a video, and then you token out a lot of car, like token out a lot of car location in Tesla's car. So there's also a translation over there. Okay, but the core part is AI for natural language processing. It actually is a translator. Okay, and this natural language processing require a lot of data structure and algorithm, and that's why make this course now still very, very important. Okay, still very, very important. Okay, give you enough introduction, and now let's go back to our course of data structure. So let's go back to the data structure. We do have a lot of topic we want to do. So what we want to do is that we are going over different data structure and then explain it, and also looking at the computational aspect of it and see if we can come up with faster solutions. Okay, so we go to this textbook. We are following this textbook, but we will jump in over from time to time. So the first chapter is introduction, and you do have the collection. This is STL in C++. So you have the array vector, and these are different things. You need to know about STL part of the story. You have to know it. We already teach it to you in level 2. Okay, so that part is okay. So chapter 1, we don't teach you. OOP, the inheritance in OOP, we also teach you already. So this part we are done. And then algorithm analysis, I think we don't want to go for this one, because this one, we do know it in AP ComSci A and the C++ part. So we kind of bypass this one. Next one, we do look at the linear structure. Linear structure, we have list and algorithm. So this one actually is too simple. So this chapter 3, we also bypass. Okay. We also teach you some of the stack and the queue or whatever. We also talk about it before. Okay, so quickly, recursion, we will bypass this as well. Okay. So you see the first few chapter, we kind of bypass it, but we will spend more time starting from hashing and beyond, so we don't repeat it. Chapter 7 sorting, we are not going to cover it. Okay, we're not going to cover it because it's also too simple. So we'll go to chapter 6 for hashing table, starting from hashing table. And then we'll go tree, directly jump into tree. And then we'll go to the graphic. Chapter 9, you see chapter 9 is very, very long. Each of the problem say preference searching, that's 1 week. Keen keyword problem is 1 week, okay? Depth first searching is 1 week. Topology sorting is 1 week. Okay, shortest problem is 1 week. Dijkstra algorithm is 1 week. Okay, these different algorithm is what we really want to look at, and they are more difficult. Okay, they are more difficult. The kind of the data collection part, we already finished them, so we don't actually emphasize on it. Okay, and from time to time we'll go back to the user code competition part. Okay. So let's look at this one called searching and hashing. Okay. Searching and hashing, we do talk about searching but we haven't talked about hashing. Okay. So searching, you have the sequential search. Okay, you do one by one searching that we know. Okay. So this one we don't repeat. Binary search, we in C++ we already covered it, so we also don't repeat. But you do know that searching and hash and sequential search and binary search, we do know the purpose of it. Next one, we will look at hashing. So hashing is a replacement for searching. So basically, this is called association memory. Association memory. Okay, this is called association memory. So you search association memory, you can see a lot of things on it. Okay. So associative memory. So associative memory is that we do look at this picture and we say this is a man. Okay, so it's actually related to the pattern recognition. You see the pattern, you recognize it and translate it to language. So it's also related to the language and fast searching. So this fast searching is very important in pattern searching. Okay, pattern recognition. Okay, anyway, you can read the art here, okay? But let's look at hash table. So let's look at the hash table data structure. So what is a hash table? A hash table is defined to insert, lookup, and remove key and value pair quickly. Okay, so this is a hashing concept. So hashing is that you do use a key to do hashing table, and then you find. So normal array is you do A0, A1, A2. And then you line them up together, so you have A0, A1, and A2. So you use index to get data. Okay, you use index to get data. So if you use index to get your data, that is actually easier, but that actually is order of n. Okay. But if let's assume this data is actually ABC. But if I want to do the other way, from your key, that's actually ABC, to get an index. Then you need to be able to use your content. So the reverse array purpose, you will need to use this hashing. Is that okay? Any question? Hello?
No.
So if this A array is actually a string array, it may be A, B, C, it may be B, X, T, okay, whatever long string is. But you don't want to actually spend a lot of time to find out your index value, the key value, the value. So you basically use a hash function to help you to find, to just get the key, the string, and then translate to a number. So this is the purpose of the hashing function. Okay. And then you want to actually use that, so you can actually get your value faster. So there's one issue of the low factor. So what is low factor? Low factor means that I have an array of 100 entries, right? and then my word got hashed to my memory. So the word got hashed to here, 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 here. But how many data being loaded? So if I use a 49 entry, but totally I have 100 memory, then my loading factor will be 49%. Is that okay? Hello? Is that okay? Helen, is that okay?
Yes.
So load factor is the percentage of the utilization of your hash table. Okay, your hash table. The next one is what is a hash function? Hash function take in your string or your data to create a value or index. So basically, this function is a randomizer function, randomizer function. Okay. It's a randomizer function. So basically, this hash function similar to the so-called crystallography. Okay, it's using division. Okay, division is not what you think by long division. It's actually a bit level division. Okay, so bit level division actually is shifting data around. Okay, so that's not really long calculation. So hashing is by division or by multiplication, depending on your hash function. Okay. So first you need to choose a good hash function. A good hash function will spread out your data into your physical domain well. So depending on your memory size, the hash function can be different. Okay. So here you do have several different criteria to choose a good hash function. Okay, to ensure the number of collision keep minimum. So hash function should distribute a key throughout the hash table, try to uniformly distribute it. That's the whole purpose. Okay, so usually the hash function is a division algorithm or multiplication algorithm based on the bit level operations. Okay, based on bit level. So usually they use a prime number to do such a thing because prime number is easy to spread out data. The so-called even number or non-prime number cannot spread out data. Okay, cannot spread out data. So let's see the spreading function. Okay, let's go back to using an easy example to explain the spreading function. If you use a prime number, okay. So we talked about this before. 3 to the power 1 divided by 7, remainder 3. 3 to the power 2 divided by 7, remainder what? 6. No. This one actually is remainder 2. Okay. Three to the power 3 divided by 7. Sarah, how much it is?
Six.
How can you fastly get this one?
Okay, so 3 to the power of 3 is 27, and then mod 7, basically just divide by 7 and take the remainder. So 27 minus 21 is 6.
A better way to do it is that this one is already 2. So you have a 2 times 3, you get 6. Since this one times 2 is this one. Does that make sense?
Yes.
So 3 to the power 4 mod 7, what is?
I'm not.
You then 6 times 3, you become 18. 18 take marked by 7 is 4. Is that okay?
Yeah.
So 3 power 5 minus 7 will get 3 times 4 is 12. 12 10 mark is 5. 3 minus 6 10 multiplied by 7 is a 5. Actually 5 times 3 is 15. Actually mark 1. So when you see 1, what happened? You'll go back to 3, next one. So basically, your 3 raised to the power 1, 2, 3, 4, 5, 6 will spread out to the remainder of 1, 2, 3, 4, 5, 6. So you see, using this one, you kind of spread out your number evenly from mark in the mark 7 arithmetic. Does that make sense? Does that make sense?
Yeah.
Yeah.
Sherry, are you okay?
Yeah.
Let's look at another one. If I don't use a prime number, if I just don't want prime number. I don't want to use a prime number. How about 2 to the power 1, 10 multiplied by 8? You got 2. 2 to the power 2, 10 multiplied by 8. You got 4. 2 to the power 3, 10 multiplied by 8. You got 0. 2 to the power 4, 10 multiplied by 8. You got 0. 0, 0, 0, 0, 0, 0. You cannot use it, right? This one apparently you cannot use it. Okay, this one you cannot use, doesn't erase it. It's of no use. 2 to the power 1, 10 multiplied by 7. You remember 2. 2 multiplied 2, 2 power 2, take out this one 4. 2, 3, 10 multiplied 7. You got 1, repeating already. So you only spread out for 3 number. You cannot spread out for the every number. So basically, this power and the prime number over here both need to be prime number. Both need to be prime number. As long as both prime number, then you can do pretty good spreading out effect. Does that make sense? Hello, does that make sense?
Yeah.
How can I guarantee? It's very simple. Why? Because any of the numbers, we say I actually have 57. That's a 10 multiplied by 3. Okay, so it's 1, then you 27, so 19. Remainder 0, right? Divide by 3, 6, remainder 1. Divide by 3, you have 2, remainder 0. So it's 2 times 3 raised to the power 3 plus 1 times 3 to the power 1 plus 0 times 3 to the power 0. So we basically have this, right? So this actually your number can be A times 3 to the power 3 plus B times 3 to the power 2 plus C times 3 to the power 1 plus 3 to the power 0. So you can say you can use a basic polynomial function. You can use a polynomial function, and that polynomial function got divided by 7. And this one evaluate at the x equals 3. Then it's already the kind of the spreading out effect for you. So that's what I'm talking about, how you design a so-called the so-called division for hash table, okay, the hash function. Does that make sense? I'm trying to use a simple case to explain for you what is a hash function multiplication and division. Can you understand it or no? Steve, are you okay?
Yeah.
How about Sarah? Are you okay?
Yeah.
Okay. But if you do professionally, this is not professional study, okay? So you just check for, let's do it, we talk for SHA 256. Okay, this one tell you the algorithm for HA 256 algorithm. Okay, let's look at this one. This one tell you this algorithm is based on what number being used for the hash table and used for computer cryptography, for the banking, okay, for many banking. So right here, you also say that you also mentioned about hash algorithms. Okay, you also talk about it. So the design of the hash function is an R by itself. And the key you pick is actually a lot of cryptography are using the SHA 256 right now as an important standard. Okay. So it's using the so-called MD5 structure. The MD5 structure is like this. Okay. More complicated, the MD5 structure. Anyway, our purpose is not to study this MD5 algorithm, but when we do study, sometimes we need to jump into the details, okay, to look at it, what it is. Okay, anyway, we tell you what is the hash function, okay? The purpose of that is to teach you what is a hash function. So the hash function is basically a multiplier base or division base, but usually they use the so-called prime numbers to do it. Okay, they use the prime number to do it. And then one thing, your table, you actually you have the ABC, and it maybe has to physical address 3. And then another one you have the CDF, it may hash to address 2. Then another one AXDR, it may hash to 10, okay, whatever. This is a hashing function. You don't have a control on it. But there may be another one called TTY, and then they hash to 3 same using the hash function. So in this case, we call it hashing collision. We call it collision, okay? And then when we have a collision, there are several ways to avoid, okay? There are several ways to avoid. So this we call it collision. There are several ways to avoid. One way is to rehashing. Another way is changing the hash function. Okay, there are several ways we can change it. So when 2 numbers are hashed to the same location, there are several ways to handle it. One way is to rehash. The other way is that you use a linked list for all of the data that all the value that actually been hashed to this location. Okay, that's another way. Okay, let's do this. Okay, let's use my slices now. So because of my slices is tougher than the textbook. Okay, let's go back to the textbook to see what they have. It's right here. Okay, so the textbook basically talk about what is the hashing and the what is the hash table. Okay, and hash table including the key and value pair and also the hash value. So they also talk about what is a hash function. So we all talk about it already so far. Okay, this one, okay. So right here they are using the mean square algorithm. Okay, so mean square algorithm is they describe what is mean square algorithm. Okay, it's taking some bits to do it. Okay, whatever. Okay, here it do show you the hash function. Okay, so here you have hash function. You put a string and you create a using mod function to create a table entry. Okay, and you calculate the sum of the each position of the integer. So basically, this one is what you have the ABC string is converted to integer, say 65 plus 66 plus 67. Okay, this number group together as the sum, and this is sum table multiplied by the table size. Okay, then you will get the hash function. This is a very simple hashing. Any question here? Hello? I think that we talked about this before in C double plus, okay? But here I don't repeat it one more time. I just want to go through the slices. Okay, so this is like something like that. So then we have collision resolution, okay? Collision resolution. Let's go to our slices. I just go through the easy part. Let's use my slice hash function, okay? This I think we will avoid it. It's too easy. So edges in memory, we know about edges in memory. This one, okay. We will jump faster, okay? This seems nothing to do with hash function. I'm sorry. I picked the wrong one. This one is hash memory. So hash memory, you are content addressable memory. Okay, it is data in address out. Okay, data in address out. So that's the purpose. So you have a hash function. Let's focus on the data collision. Okay, so you do have this hash function in C double plus. You do store the key value pair. Okay, so you use the key, your string, hash function to hash to a certain bucket. The so-called bucket is that because you may have multiple data there as a linked list. So we call it bucket. But if you don't have the multiple value, we just call it an entry. Okay, so sometimes this is bucket, sometimes this is entry. And in the search time is order of 1. Okay, this one, okay. So here talk about hash function. Okay, it's okay. Now this one we do have hash function. hash function, this one. So hash function is a function doing calculation. We do explain it. It's usually using prime number. Okay, you can use some mod table size or every sum entry times 37 the prime number. You see, you use a prime number to spread out the data mod the table size. So usually the power come here. So basically it's A is you have A string. So it's A strings each location A0 times 337 0, A1 times 37 1, something like this to spread it out. Okay, you sum them together. Okay, these are some sample hashing function. Does that make sense? So the example in the website, it use a 1. It use a hashing table of 1. If you do this one as 1, it's this one, it's this version. So this version actually does not really spread out well. Okay, it won't, because it actually based on your data, it's very easy to get stuck at certain location. Okay, so that's a hashing function. And then you have different separate chaining type. Okay, using the linked list to do it, or you can do open addressing for double hashing or linear hashing or quadratic hashing. Here we focus on these two solutions. Okay. So first one is with bucket. With bucket is the first one, searching chaining. Okay, searching chaining means that you search for the entry and you hit it. You know the data is, but the problem is that two data may be hashed to the same location. Then you need to use a list to keep all the data right here. Okay, so here it actually is a list. It also is a set. Okay. And low factor is the number of the element divided by table. We talked about it already. Okay. So that actually is a simple idea. And then next one is probing method. Probing method means that when you have a collision, say you click, you got hash to here, but this one, it also hash to here. So what can I do? I actually jump certain spaces. Say I jump by 4 or jump by 40. That's called open addressing linear probing. Linear probing means that I just jump a certain linear step. Does that make sense? Hello?
Yes.
So that's the way we do it, okay? That's called linear probing. But linear probing, sometimes you got probe several times, okay? Okay. Then another way is that we do quadratic probing. So when that happens, you kind of doing quadratic on its content, the numbers, in order to hash to a different location, okay? That's called quadratic. So usually quadratic performance is better than linear hashing, okay? Performance better than linear hashing because it's spread out more uncontrollable locations. And you can do hashing, then use a second hashing function. This is called double hashing, okay? Double hashing. Okay. So here talk about how to do double hash using two hashing function. So you see here, it use a lot of mod function for it, okay? Okay, then here we do have the hash code for the Java language, okay? Okay, here he primarily talk about some of the hash basic idea, okay? Next one, let's look at the hash set. Okay, hash set. Hash set is also order of one, okay? So hash function, you have key and value. And hash set, you don't have value, okay? So you don't have value means what? You can think about they are of the same value. So that's when your key is ABC, then you store 0. Key is CEF, you also store 0. And then your SGR, you also store 0. So basically this one you don't need to consider. You just hash the key, but if the data is in the memory, then we know it exists, so it becomes a set. Is that okay? Steve, is that okay?
Okay.
So what does this indicate?
Can you repeat that?
Hmm?
Can you say that again?
What is a hash set? So Sarah, what is a hash set?
It's like kind of like a hash map. Like it's like
Yeah, what's the difference between hash map and hash set?
like set, like the items has to be unique.
Hmm? One more
I'm not
time.
like I'm not sure like what's different, but like set, like it's like the items have
Set,
to
you
be
only have the key, you don't have the value.
oh, okay.
And what does this say? What does this indicate?
Like it's not like key value pair, like it's you just store like elements instead of having like a key and then value to access it like that.
Yeah. How about Helen? Helen, can you describe in your words?
It's like instead of having like a value for a key, it's more like the value is the index that the key will be stored at. And it's like unordered because of that, because you're only like inputting like whatever data you're gonna store and you put it at whatever position is returned by your like hash
Yeah,
function.
basically you can store a 0 there, that's your value, that's a prime, okay? Or you just use your key to put over there, okay? You just put your key. So basically this one hash set, you just want to know about whether it actually is a hit or not. Okay, here whether it's a hit or not. You hash to a certain location and this is occupied, mean that ABC is inside the set. Okay, or you have a different way of doing it. You can put a linked list for this ABC right there or CEF right there, but you don't store your value. You store your string over there. Okay, then actually you know that this is your data is in the set or not. Okay, so basically one more thing that we can say is that hash map can be implemented by a hash set can be implemented by hash map. Hash map can replace the hash set. Okay, so usually hash set is simpler. So right here, let's look at the implementation. Okay, well, implementation part of it. We can insert content and a bucket. So we can use a vector of the set of the string for the names. Okay. So here, because you are using the hash table, and then your string is a set. So this is set by itself is a hash table. And you store an array of, so this array is a physical memory, right? Is that okay? So your hash function will set hash to array index. Your input is a string, and then you hash it to it, okay? So the bucket can be implemented as a linked list. Bucket happens when you hash to a memory location. If there's a condition, you need to put a set or linked list. You can also implement it by set. You can also use array list to implement it, okay? Up to you. So here show you the data structure for hash set. You have set of string, you call it hash set, new hash set, okay, hello, whatever. And you get the key to different location, key and value pair in different location, okay? So that load factor is the amount of bucket that has element and has not and total, okay? You divide your total number of element over the bucket. Rehash, you use a rehashing function. And they are insert, you actually doing hash and then put the data into the hash memory. So we do have insert function doing this to hash to, this one is a hash function, okay, this one. Okay, and insert the data into it. This insert function to the table. And you can use a contain function to check if the data is in the hash table. Okay, this one is the check function. And there is a rehash function to rehash the data back to the different locations. Okay. So here we do have a case study. You can download this code from internet. Okay, well, our course. We give you the CS45 course. Okay, there's a hash table, you can download it. Okay. Okay, the whole code is right here. Okay. So basically inside here, you do have a length hashing function. Okay. And then hash table with the set of string vector. There's a constructor, you have contain function, insert function, okay? And print function and rehash function. These are different functions supporting the hash sets, okay? Okay, so today we basically cover these. I will give you these slides, these chapter slides. Chapter 2 hash set, okay? Study, we will continue to give you more topic in hash table next week, okay? Any questions so far? Let me
No.
keep you the set, okay? One more thing I will do, okay? One more thing I will do. I'll give you this one for you to start. I'll give you the chapter 1, the hash functions, and chapter 2, the hash set, okay? Next week, we'll talk about hash map. So, no question. Any question about your competition part, the user code problem so far?
No.
No? How about Sarah? Do you have question over there?
No.
No? Let's see, time. So that would be next week, okay? Next week we have competition. Anyone need help, let me know, okay? If you need help in here. Okay, take a look on the training side. Let me see if the problem not too big. I'll go over one problem. Okay. Last time we finished the, let's see, session 1. I'm sorry. Chapter 1, let's see, we do finish this one. Nevertheless, we finish complete search. Complete search part. Dual palindrome we finish, we know. Next one, greedy. Okay, let's see. Greedy algorithm. I think we never work on any one of them. Okay, let's go for this a little bit of a greedy algorithm. Let's get started. So we can continue, okay? So next one is greedy algorithm. Let me find my slices. Starting from for the greedy algorithm. We finish, so we start in a U13 greedy algorithm. So let's look at greedy algorithm. So complete search, we search the optimal solution in the solution space. Okay, greedy algorithm, we do not actually search the whole solution space. Instead, we are assuming that we are greedy on local optima, and then you can solve the problem. It's called greedy algorithm. So greedy algorithm, that if they ask for the maximum solution, then we actually try at the local part, the small question part, we get the maximum. So for example, that if they ask a question of how much money you can earn over the next 20 years, then every year you make the maximum income, then we can guarantee that over the next 20 years, you'll get the maximum income. Is that okay? That's the basic concept of the greedy algorithm. Steve, is that okay so far?
Okay.
Steve, have you ever tried the user code competition so far?
No.
No? Do you want to?
Yeah.
You
I wanna
should try. You should try just go there to experience once, okay?
Okay.
We will see. You actually need to figure it out. Just go for it, okay? Don't even ask question before you join. Just go and test it. You have an account, you just go there, okay? So optimization problem, usually we have most optimization you want to find, but just greedy algorithm is that when you want to find the best algorithm, you hope that you can choose every single local optima. Some algorithm you actually go for the local maxima, you will find a global maxima. That's called greedy algorithm. Some of the problem you cannot do it in this way. Okay, but so it depends on what problem it is. Okay, so counting money. So each step of the counting money, you want to make a 3.39. Okay, you have a $5 bill, $1 bill, this kind of things. So if you use the most number of the $5 bill, then this is a greedy algorithm, right? Then you use the most number of the $1 bill, and then you use the most number of the 25 cents, the quarter coin. You use that to count money. This one is a greedy algorithm. You can figure out what is the minimum number of the coin or bill that you can pay for the money. Okay, this is one example of the greedy algorithm. Okay, and in some system like Chrome dollars, come with 1 cron, 7 cron, and 10 cron. In this case, the greedy algorithm doesn't work. Okay, so this only tell you that greedy algorithm sometimes works, sometimes doesn't work. So when you go for a usable competition, you want to use some of the algorithm that's greedy. Greedy means that your local optimum, you are assuming it's a global optimum. You have to make sure that the algorithm is greedy, okay? You need to make sure that. So interval scheduling problem, let me set a limit, okay? Okay, there are quite many examples. I don't think I can finish today, okay? So let's actually stop right here, okay? So we talk over the greedy algorithm so far up to the value of the greedy algorithm. Next week, let's get started from interval scheduling, okay? Is that okay? See you next week, okay? Bye-bye.
Bye, thank you.
Bye,
Bye-bye.
thank you.